In this video, I'm going to show you how to sketch some graphs when the graphs or the equations are in turning point form. So I've written up here the general form for turning point form. Just a reminder that A is the dilation factor, H is the horizontal shift, and K is the vertical shift. And we said that the turning point was at the coordinate where value of H and K. So let's go into some knowledge about the graph x squared. Just remember, when A is a positive number, we're dealing with a positive quadratic, a positive parabola, which I call a smiley face. And when A is negative, we're dealing with a unhappy face, so it's a negative. Also, when we're sketching a graph, it's really good to show, where possible, the turning point, coordinate of the turning point, the Y-intercept and the X-intercept. Now the X-intercepts aren't always possible, particularly if the graph is above the X-axis, then it doesn't cross the X-axis, or if we can't, we just simply cannot solve the quadratic formula for when Y equals 0. Also think it's really helpful when you're sketching to set out your working by saying, right, I'm finding the turning point and underlining the Y-intercept and the X-intercept as shown here. And then your working can literally follow a nice column down and you can show your working really well. So let's go straight into some examples. We'll start by sketching the following quadratic relations, labelling of course the turning point, the Y-intercept, and where possible those X-intercepts. So let's start with Y equals 3x squared. Now this is a basic graph. We can see here that I've written next to it the turning point form, and we can see, well, where there's no value of H and there's no value of K, however there is a value of A. The value of A is 3. That means that the normal graph of x squared has just got a dilation factor of 3, so we know it's upright, but it's just slightly narrower than x squared. Now in a sketch, unless the graph of x squared is there, it's very difficult to show it's narrower, and that's okay. And I've drawn my axes here, and I've also underlined Y-intercept at the point when x equals 0, so I'm going to show my working for that. So let's substitute when x equals 0 into the equation, and we get that y equals 0. So we know therefore that the y-intercept is 0 when x is 0. We also know from our knowledge of the graph of x squared that the graph of x squared cuts through the origin, which is 0, 0. So therefore that's its turning point. Now when we're sketching, it's always good to show a continuous line, and you should show arrows because it's going up and above, obviously, well, it continues. And here you should label turning point 0, 0. Okay, let's go on to a second example. Now I'm going to draw the graph of y equals x minus 2 squared. And you can see I've already set out my working, the titles I'm going to use. Over on the right, I'm just going to write the general form for a turning point, just so I can get my head round what I've got and what I haven't got. So you can see the value of A is 1. Alright, so therefore it's just got the same thickness as x squared. Let's look at the value of H, the value of K. Well, H within this is 2. So H is 2, so therefore, and K is 0, so therefore the turning point is at 2, 0. Next, let's look at the y-intercept. So the y-intercept happens when x equals 0, so we're going to substitute x equals 0 into our equation. 0 minus 2 squared, minus 2 squared is 4, so our y-intercept is at 4. Once you've found the y-intercept, you then consider the x-intercept. But let's have a look. The turning point here we can see is sitting at 2, 0. And that's the most minimum point because the dilation factor is a positive number, so therefore it's a happy face. So this is the most minimum point. So we're not actually going to have any x-intercepts. This graph is not going to cut the x-intercept. So if we try and solve when y equals 0 for this equation, we're not going to get anywhere. So knowing that, we will now go and sketch the graph. So don't forget you need some axes. And I'm going to just draw a smooth parabola. Okay, and I can label the points in. Don't forget those arrows to show it's a continuous function. And then placing on there the coordinate 2, 0 for the turning point. And then obviously the fact that it goes through the value 4 as the y-intercept. Okay, so 2, 0, there we go. I'm now going to go on and do a harder example. So let's look at y equals minus bracket x plus 1 all squared plus 4. So let's have a look at the a value. We can see that a is negative 1. Remember, I often like to write down the general formula for turning point form just next to it so I can tell what I'm looking for. So a is negative 1. That tells us that the graph is going to be an unhappy face. All right, because so it's a negative quadratic. Let's also have a look at the value of h. Well, h is negative 1. And k is positive 4. Therefore, the turning point is at negative 1, 4. Let's look at the y-intercept. Now, the y-intercept occurs when x equals 0, so we'll show the working for that by substituting in x equals 0 into our equation. So we've got minus 0 plus 1 all squared plus 4. So working that out, we've got 1 squared is 1, and that becomes minus 1, plus 4, we get the y-intercept to be 3. Now let's look at the x-intercepts. Remember, we substitute y equals 0 into our formula, so we've got 0 equals minus x plus 1 squared plus 4. So what I'm going to do is, because I've got negative there, I'm going to move that over to the left-hand side so it's positive. So I get x plus 1 squared. Just struggling with a pen again. It's being silly. Excuse me. X plus 1 squared is now onto the left-hand side equals 4. Then I'm going to square root both sides. Remember, when I square root, I get two answers. So on the left, I'm left with x plus 1, and on the right, I'm left with plus or minus 2, because the square root of 4 is plus or minus 2. That leaves me with either x plus 1 equals 2, or x plus 1 equals minus 2, and of course solving each of those gives me x equals 2 take away 1, which is 1, or x equals minus 2 minus 1, which is minus 3. So our two x-intercepts are at 1 and minus 3. Now, of course, we're going to put all those points on a sketch. I'm going to draw some axes. And don't forget, I've got an unhappy face, so just draw one of those and then place on the most important point. So our y-intercept was at 3. Turning point is actually, that's the wrong side. Never mind, doesn't necessarily matter. I should make it proper though, so let me just rub that out. Let's have another go. That's better. So I can show that the y-intercept is lower than the turning point. Obviously, I'm trying to do the right thing. Turning point is at minus 1, 4. And then these x-intercepts were at minus 3 and at 1. All right. Last thing I need is those arrows to show it's continuous.